Hey everyone, how it goes, and welcome back to Computer Science 146. Today, we're going to go over even more programming review. More specifically, we're going to discuss exceptions and file input and output. Exceptions are a way that we can basically alert and handle these very exceptional runtime events. Now, if you remember back, 3 of the most common errors in computing are syntax errors, runtime errors, and logic errors. Exceptions focus on runtime errors, so some kind of exceptional case that might come up through the process of the program. Now, when it comes to exceptions, there are 3 essential elements to know about them: knowing how to create an exception, knowing how to use the exception, and also knowing how to handle the exceptions. Now, with the first 2, creating and using the exceptions, we're not going to focus on that too much in this course. However, as a quick example, whenever we need to create an exception, all we do is use an existing exception, and then using inheritance, we extend that exception to make it a more specific version of an exception. Also, the only data that's usually in an exception is some sort of error message, some sort of string message. When we're writing our own exceptions, we only concern ourselves with writing the constructors and thus setting that error message. As we can see over to the side, the syntax for creating an exception is to define a class and have it extend some sort of existing exception, and then write the constructors, utilizing super in order to set the exception message. An example of this would be, maybe we're writing some sort of program to calculate values. We know we can't divide by 0, and that is an exceptional runtime case. So in order to handle this, maybe we create a more specific version of this kind of exception, which is called the divide by 0 exception. From there, we just simply write its constructor and then utilize super to write the error message, divide by 0 exception attempted to divide by 0. Now, the other side of this is using the exceptions. So when these exceptions do come up, how do we use them? We have to take a look at the actions. In other words, we have to take a look at the methods that could raise these exceptions. Whenever we are aware of these exceptional cases, what we do is include that in the method definition. So we use the reserved word throws followed by a series of exceptions. Now, when the exceptional case occurs, we then use the reserved word throw followed by a call to the exceptions constructor. An example of this would be, if we had to calculate this value, and this value could cause some sort of divide by 0 exception or some sort of unknown operator exception, now this indicates to the other programmers that this method can cause these kinds of exceptional cases, and what we have to do is handle those cases. Along with that, when we're defining this in the method definition in Java, we use the word throws. But whenever the exception actually happens, so let's say that there's some more code here, but if the denominator is equal to 0, then what we do is throw a new divide by 0 exception. So this is the reserved word to throw the exception, and this is the constructor call to construct the exception. Knowing how to create exceptions and knowing how to use exceptions is very important. But the focus of this class is going to be about handling exceptions. This becomes more important later on. Whenever exceptions can happen, what we need to do as programmers is put those methods, put those calls in what's called a try and a catch block. Whenever an exception occurs inside of that try block, inside the body of the try, then what happens is it is immediately caught by the most appropriate exception. You can have any number of catches, and the way that you need to organize them is from the most specific exception first, and then the least specific exception last. Now there's also another part to try and catch, which is called finally. Now this code runs regardless if there is an exception or not. We're not going to focus too much on that part in this course. Now, as a quick example, We had defined previously that this method calculate value could throw different kinds of exceptions. So if we're going to call this method, we have to enclose it inside of this try, or else we'll get a syntax error. After that, what we're doing is handling the different kinds of exceptions. One of them was a divide by zero exception, which is handled right here. The next one was an unknown operator exception, which is handled here. And finally, it's generally a good idea to always include the catch-all exception. This is the exception that is already built into Java, and every other exception is derived from this base exception. There's a lot of different ways that we can handle exceptions, but one good way that we can consistently do this is for each one of the objects, so we name them E right here, we call E and then the method print stack trace. What this does is print out everything that is currently in the call stack that resulted in this exception. This can be extremely good for debugging because more often than not, it's not what's going wrong, it's where it's going wrong. Exceptions are very important to know because file input and output is fraught with all sorts of exceptions. All sorts of these exceptional cases that we need to handle specifically for file input and output. Now the idea of file I/O is this allows a program to both read from files and write to files in the secondary storage. Now if we remember back, the secondary storage is roughly your hard drive. This is the long-term permanent storage that we use to store the programs and the files associated with programs. Before we get to the process of file input and output, there are a couple of details that we need to go over. First of all, we have to know what a file system is. This is the way that the secondary storage, your hard drive, is organized. We can assume for the most part that we use this thing called a directory, which has a tree-like structure. In this course, we're going to be going over trees a little bit later on. But the thing to keep in mind is there is this parent and child relationship from one level to the next level. We have these containers, which we call folders, which are the things that hold files. The starting point of a directory is referred to as the root. So if we have the example over here, we might have this root computer system, which might have two different hard drives, C and D. From there, we have some additional folders, like maybe this is a Java folder, then inside of here, this is the project folder, and then inside the project folder, we have two folders, source and binary, and then also within inside a project, we have some file, and inside of source and binary, we have some other files. We have to keep in mind that there are two different ways to represent addresses. This is the path, starting from the root, how we get to that file. There's one version of a path that's called absolute, which is simply just the entire sequence that we have to go through, the entire number of folders we have to get to before we can get to this file. So this file's right here. Its absolute path would be C, Java, project, and then the name of the file, some file txt. Now we can also talk about a relative path as well. So a relative path basically assumes that we start from some given directory. And then from there, we can either access that directory or go up and down the directory structure. Inside of Java, since the projects are considered basically the root folder of the programs, if we call /, this is going to indicate that this file is right here inside of the project. Now, as we know before, the way that we organize files for these projects is in a source folder, which is going to contain our .java files, and then the calculated binary files, which is our intermediate bytecode, our .class files. One other quick thing to note, whenever we are reading from files or writing to files, keep in mind that these need to be in the project's directory, right here. If it's inside the source or the binary folder, it may not find the file you're trying to access. Files that we're reading from and writing to should be in the project's root folder right here. We need to understand the structure of the file systems, but that's not the only part to this. We need to understand files themselves. Files are assumed to have a file format. This is how the information in the file is grouped together. One general way that's done is grouping together file information into sections called the header information and the body information. Header information usually contains metadata about the file, and the body data is what contains the actual information. Think of it this way. If we have like an image file, some of the header data might be the image's dimensions. So what is the length and the width of this image? The body information would be the color data. So given this dimension, at this position, at this pixel, what should this color be? You would need to have both in order for this to be displayed correctly. Not just how the information is grouped together, but also how is the information separated in the file format. And there's a lot of different ways that we can separate out information. One technique is to use a character or a byte length. So how many bytes do we need to read in for this section, or how many characters are we going to read in that separates this part of the data from that part of the data? Another very common technique is using this thing called a delimiter or a separator. Now these are very special characters that basically separate out the information. They are unique to indicate that we have this information over here that is separated by this special character, and then we have the next information beside it. Two ways that we can group together common files are plain text files and binary files. Plain text files are simply readable. It's readable by humans. And these are the types of files that we're going to be using throughout this course. Now, the alternate version are binary files where all of the information is stored inside of bytes, which is readable by the machine, but in general not readable by people. Now also, there are some very common file formats that we will be utilizing throughout this class. One of the first ones is just called a plain text file, and it's just readable words. You can think of this file as basically being like a book. So the information would be separated by some kind of space. We can consider this information being like a word. So if we're reading through a novel, that's how we're separating out the information. Words are separated by using some kind of space, whether it be a single space, tabs, inlines. Either way, each one of the information, each one of the words is separated simply by a space. There's another very common format that is called tab delimited. This separates informations by using the special character tab. Now, as we can see here, this slash right here indicates that this is an escape character. This is the representation of a tab. Now also, this information is further separated by a different delimiter, an end line. You can think about tab delimited files as basically being a spreadsheet. Think of each one of the rows being indicated by the inline and each one of the columns in a spreadsheet being separated by the tab. A similar but alternate version of a tab delimited file is also called a comma separated file. And basically this is the same thing, except instead of using a tab, it uses a comma. Using the file system, we know how to locate the file. Understanding the file format means that we can read and write the file. But now we need to talk about the mechanism to actually do that. We utilize what's called streams and buffers in order to have input and output. Now, a stream can be thought of as simply a sequence of data, usually assumed to be first in, first out. A buffer provides some temporary storage that will hold the information that is being streamed to it. Now, buffers will hold onto this information until it is removed, and sometimes that's called flushed. Also, it's generally assumed that streams only flow in one direction. Looking a little more specifically, system.out inside of Java is a link to the standard system output stream. It is the way that we print out to the console. So every time that we've been doing that, every time we've been passing that string inside of the method print line, what happens is the program streams that information to a buffer, and then that buffer is flushed and is printed to the console. So the stream flows in this direction. Now, if we were getting information from the console, It does it in a very similar way. The information is streamed to this buffer, and then from this buffer, it is flushed into this variable right here. Keep in mind that streams generally flow in one direction, and we use streams and buffers in order to have input and output, and especially with files. Going more specific, let's take a look at file output. I highly recommend that in Java, if you're doing file output, use what's called a print writer. Now, this is a class that creates an object that we can use to write files. However, it is not pre-built into all Java applications. We would need to import java.io.star in order to use that type. Whenever we're using a print writer, we have to both construct it and use it inside of a try and a catch block. There are a lot of exceptional cases when it goes to file input and file output, so we have to be able to handle those exceptions. Once a print writer has been created, you basically use the object just like you would use system.out. In fact, it has two methods, one called print, which will print on the same line, and another one called printLine that will print to the next line. Now, as we are streaming this information to our secondary storage, to our hard drive, it is so very important to remember you must always close the file's stream. If we forget to do that, it's as though you forgot to hit save on some sort of document that you were working really hard on. This information that's in your main memory, which is volatile, may not get flushed out to the hard drive. This ensures that all the information that was contained inside that buffer makes it to the file. But also really important, if we forget to close this stream, it creates a potential resource leak. Your operating system may think that we're still accessing this file even though the program that was accessing it no longer is running. We have to indicate to our system that we are done utilizing this resource, or else we may have to restart our computer in order to gain access to that file again. So always remember, close the streams. Looking over at the syntax, in order to create an instance of a print writer, all you have to do is use the type print writer, and then construct a new print writer, construct a new file output stream, construct a new file, and then include the file's path along with the name. This version of it will create or overwrite a file that's in that directory. Now, if we wanted to add to the file, if we wanted to append information to an existing file, the only change with this is including this boolean here saying true. This will mean that our file output stream is going to append to this file. Printing to a new line is just like system.out, but we just use the print writer's ID followed by printLine, and similarly, if we're printing to the same line, we use the method print. Now finally, once we're done with all of the operations on the file, this will close the print writer, thus closing the stream. Now let's focus on file input. Now let's take a closer look at file input. I highly recommend for this class to use the type scanner to read these files. As it was mentioned before, a scanner can scan any sort of thing. In fact, more specifically, a scanner scans streams. This means you can use a scanner for the standard system input, system.in. It can scan what is entered into the console. You can also use a scanner for a file. You can also use a scanner for networks. You can also use a scanner for strings. Anything that can be streamed can be scanned using a scanner. Now we must remember to include this by import Java in util. Now if we're creating a scanner that's reading from a file, it has to be constructed and its operations must be used inside of a try and a catch block. There's a lot of exceptions that can happen from reading from a file. The great thing is we've used scanner a lot, and we're very familiar with a lot of the methods like next, next line, next int, next double. All of these methods can be used to read files. Another thing to keep in mind is the scanner reads from left to right, then top to bottom. Just like when you're writing stuff in the console, you can't go backwards and access previous information that was entered into the console. It only reads what was immediately entered, one at a time. Now, just like with the print writer, the scanner has to be closed. The file's input stream has to be closed. Now, the syntax to set up a file scanner starts out very similarly. The only major difference is instead of system.in as the parameter, we pass in a new instance of this file given the path and the file name. So now this file scanner is reading this file. Some very common methods that we should consider using is if we're reading the entire line. So starting from wherever the cursor starts in the file up until it encounters a next line, we can use the method nextLine to basically read this entire string and store it into the string variable. Now maybe we wanted to read up until the next space, and this can be any kind, so a single space, a tab, inline, whatever. If we were reading a file in this way, so word by word, we can use the method next in order to get that word. If we're specifically looking for an integer, a double, a boolean, then we can use nextInt, nextDouble, or nextBoolean to get that information. And finally, to ensure that we are done with using this and we have finished with this stream, we just basically call the method close in order to close the scanner's stream. Before we get into some examples, I have to mention that usually reading from files is fairly difficult for early programmers. There's a couple of tips I will recommend when it comes to reading from these files. First of all, use the type scanner. Scanner allows us to do things that might be more difficult if we were using some other means. Next, make sure that the file path is correct. I strongly recommend, especially for this class, to use relative paths. Put all the files that you're accessing with your program in the project's root directory. This is not the same thing as the source file directory, and it's not the same thing as the binary file. It should be grouped together in the project's root directory. When you're reading a file, know the file format. Understand how the information is grouped together and also how that information is further separated. Keep in mind, files are read left to right, then top to bottom, and you cannot go backwards. Finally, always close the scanner once you're done reading the file. Over to the side here, we have some pseudocode describing methodologies in how to read some of these files. Like for instance, if we're reading a plain text file, think of this as though the program was reading something like a book, where we know all the information is separated by some kind of space, single spaces, tabs, inlines. First thing you do, open the file. Next, you read it word by word using the method next. After you have read that in, process the information. What does that word mean, or what are we trying to accomplish using that information? Finally, we repeat step 2 until the end of the file has been reached. Another common file format that we will be using a lot in this course is tab-delimited files. Now, reading one of these has a very common sequence. Step 1, go ahead and open the file. Now next, we know that tab-delimited files are separated using tabs and also inline. What you should do is read the entire line. Use the method nextLine to read the whole line. Then you split up the information by using the tabs themselves. After that, you check if the information is valid and then process that information as long as it's valid. We keep repeating step 2 until the end of the file has been reached. We are going to go over how to read a tab-delimited file in a future example, but for right now, let's take a look at a problem that involves reading a plain text file. The problem that we're going to solve is we're going to create a system that basically reads a script. It reads a script and it finds the number of instances that a word appears. Let's go ahead and go over to the code and see this. The movie script that we're going to analyze is from Shrek. And so what we have right here is the project already set up and ready to go. So we have our project here, and we've already created this base class, which has our entry point, the main method. We've set up a keyboard scanner, and we've prompted the user basically to enter a word. And the purpose of this program is it's going to read the Shrek script and then tell us the number of times this word appears in that script. Before we can read that script, we need to include that in our project. One thing that you can do with Eclipse is simply enough, if you have the information somewhere. So what I'm going to do is basically drag this file into our project, copy it over, and now this plain text file is included inside of our project. To also point this out, if I right-click this and I go to Show in System Explorer, what we can see is this is the folder. This is the folder for our project. This project folder holds the source and the binaries for our program. Now, where we have put the file that we're going to read is in the root directory of this project. It's right here. It's not inside a source. It's right here inside the project's root directory. Make sure the files that you're going to use are in the root directory. Now, the next thing that we need to do is we need to look for this word. What I recognize immediately is I just said a verb. I need to look for this certain word and give back the number of times that it appears. Well, this feels like a separate action. This feels like something a little different. And as we know from code organization, whenever we recognize a verb, that usually indicates there should be a method. I want to keep this as simple as possible, so I want to be able to write this method and call it directly from my main method. We also recognize that the main method is static. This means in order to directly call another method, that other method must be static as well. So to first start out, we create a public static. Now what we need to think about is what we are returning. So if we're looking for this word, this method should return the number of times that it appears. So let's just return an int. Now let's give this a good identifier, like look for word. Well, what word are we looking for? Well, we have to pass that information via a parameter, like this. So we look for this word, and then it returns the number of times this word appeared. Now, as this method does not have a void return type, it must return that value, an integer. We're going to go ahead and set up a variable int ret, and I'm going to assign it to 0. I'm then going to make a little bit of space, and I'm going to return this return value. From there, what we need to do is open up this file and read it word by word, counting the number of times this word appeared. We need to first enclose this inside of a try and a catch block. Inside the catch, I'm going to go ahead and call e.print stack trace. So if there's an exception that occurs inside of this try block, it is caught by this exception and it prints out where it went wrong. Now we need to open the file. We're going to create a scanner, file scanner, and now we're going to construct it, new scanner, and we're going to pass in the parameter, new file, and then inside of here, we're going to include the file name and its path. /Shrek.txt. Now notice, we have a syntax error currently on file. And this is because when we're doing file operations, we must always remember to include not only import Java util scanner, but also import Java io.star. So now we have constructed this new scanner. we have now created this stream from this file that can be scanned by our scanner. What we need to do next is look at it word by word, while the file scanner dot has next. If this were not true, this means that we basically do not have anything left. We're at the end of the file. So now what we need to do is store that information that we read from, that we scan through the file. I'm going to create a string next and assign that to the file scanner dot next. This reads it word by word until we don't have any words left. Now that we have acquired the information, we need to process it somehow. In this case, what process means is count whenever this word matches this one. So what we're going to check is this: if next. Now, as we know, a string is an object type, and we need to check its contents. So we're going to use dot equals word. Now, if that's true, we take our return plus plus. Now, outside of this while loop, still inside of our try block, let's go ahead and file scanner dot close. That way, we close the stream. So now that we've written the method, let's go ahead and prompt the user the number of times that this was found. We're just going to write a very simple system.out.println right here, but notice that we call the method look_for_word here. This method is then pushed on top of the call stack, and it looks for all the words, calculates this return value, and then this becomes the return value. So to test this out, let's go ahead and look for the word donkey. How many times does that appear in the Shrek script? According to this, 2 times. This doesn't seem quite right. And it's not. The thing that we have to understand about processing is also understanding about the methods that we're using. When we call equals, this means this word needs to match that word exactly. It is case sensitive. So we don't want it to exactly be that. Maybe we want to make it not case sensitive. So let's see if we can adjust this to make it more correct. I'm going to go ahead and comment this out, and let's try it like this. If next, this string, dot equals ignore case. Okay, this should be the right one. If we ignore the case and the word, then this should give us the correct value. Let's run it again. Now let's enter in donkey. And now this says 269 times does that appear. Now this would almost seem correct, but if we were to open this inside of a word processor and look for the number of times this word appears, there are more times than just this. But why is it that way? Once again, it comes down to a misunderstanding. So when we did it this way, what we're seeing is this word, does it exactly match that word? Now in this version, if we ignore the case, does all the characters match this one and that one exactly? But maybe we're looking for the number of times it just appears. So if we did it in this way, this would disallow us from things like a possessive. So donkeys with an apostrophe S. Even though donkey still appears in that word, because it has the extra characters like that, it's not registering that as a word. If we wanted to make this as precise as possible, we need to know about another method that is built into strings. I'm going to comment this out once again, and I'm going to rewrite this. If. Now what we need to do is take next. We do not care about capitalization. So to ensure this, we're going to do next.to uppercase. That way, all of the characters are assumed to be uppercased. Instead of equals and equals ignore case, maybe we just want to see if that word dot contains this word also to uppercase. So since we uppercased both of these strings, the case is ignored. Now we're using this different method called contains, which simply means, does this word at least contain all the characters in order in this one? Let's run this and see what we get. Once again, let's enter donkey. And now the number of times is 326. And this would be the correct number of times that the word donkey appears in the script. Understanding file I/O means that we have to understand how files are organized. We have to understand its structure, the file structure. We also need to understand how the file is formatted. How is the information separated out? Another element that we just demonstrated is understanding the different methods that are built into strings. In a lot of cases, the difficulty of reading a file comes from using some of the string methods. Now, before we finish this, let's go ahead and take a closer look at some of the elements of this. Let's say over here we have the code that we have developed to read this script, and over here is the file that we're reading. And notice this thing right here. You can consider this being like a cursor. So if you would open this inside of a word processor, this is where your cursor would first start off. You should also think about this as how it reads the information from the file. So if we start with this part right here, we have not reached the end of the file, so we do have something next. When we enter this part here, what we're calling is filescanner.next. What this does is, starting from that cursor all the way up until the first space, it captures all of that information and then stores it inside of that variable. Now once it's done that, what it does is it moves the cursor to the next position. In other words, it moves it past all of that space. Then we check this again. So we haven't reached the end of the file, and so as soon as we call next, it's going to scan through and it's going to capture that information and also store it in the variable next. Now once it's finished that, it moves the cursor forward. Always keep in mind, you read files left to right, top then bottom. This has been a discussion about exceptions and file I/O, and we're going to be using files a good bit throughout this course. With all that being said, I'll see you next time.